as the top of the notebook says, you guys are welcome to save a copy of this notebook, or you can just keep a copy of the link, but it's probably better to make a copy of the notebook so you can make your own changes. You can do that by going to File and then Save a Copy in Drive. Okay, it's 8:02, so I'll get started. So welcome everyone to the Data Science Libraries and Tools Workshop. My name is Jack Douglas. I am the VP of Education for the Data Science Club. I'm on co-op right now, and I'll be entering 3A of software engineering in the winter. My Discord and LinkedIn are on the screen, so you're welcome to contact me and connect with me through Discord and LinkedIn respectively. And I've sent the notebook into the chat. So you guys are welcome to make a copy, as I mentioned a few minutes ago. In case there are newcomers, you can make a copy by going to File and then saving a copy to your drive. That way you can have it as a reference for later on, maybe during the Datathon. And as well as I've provided a ton of resources throughout this notebook. So it's just, it'll likely be a useful resource for you for this weekend and potentially beyond. So first, a quick overview of the workshop. So the intended audience of this workshop is for beginner data scientists. I'm going to be talking about notebooks, data, some of the data sets that some of the dataset websites that we've provided on the dev post and that I talked about in the opening ceremonies presentation. So I'll be just looking through a few of them and just to show them to anyone who hasn't used them before. I'll be talking about Pandas and Numpy, two libraries that are used for handling data sets and applying computationally taxing operations on that data. Those are the two big data science libraries for those purposes respectively. And then I'll be talking about Matplotlib and Seaborn, which are two plotting libraries. Then I'll be talking about Scikit-Learn, which is an open source machine learning library with a lot of that supports a lot of different algorithms. And I'll be looking at three particular applications, as well as touching on Tensorflow and Keras and some basics about how you might get started if you wanted to use neural networks this weekend. Again, because this workshop's only an hour, I won't be able to get super in depth about a lot of these libraries. More so, the point of this workshop is just to provide some resources for you and give some basic functionality for these libraries so that you can potentially so that you'd be able to work with them potentially this weekend. And I've provided some links for the documentation so you can learn more about how you might implement them and hopefully inspire you to work on some projects if you guys are a little worried about what you want to work on. So let's let's begin. So first, notebooks. So notebooks are an essential tool that data scientists use to quickly write and execute code. So this website that I'm on right now, this is called a Google Colab notebook, and that's one of many different types of notebooks. I've listed a few others. Jupyter Notebook is a common one, and Databricks, a sponsor of ours, also supports notebooks. And so I provided links for those two alternative notebooks that you can check out if they interest you. One reason that I chose Google Colab as the notebook of choice is because it is easy. You're able to mount it into your Google Drive. So that's one big benefit of using Google Colab. So I'm able to access all my files. As well, it offers a hardware accelerator, which is super big, and it's free of charge. So I'm able to train models that would normally be very difficult on like a regular Mac laptop, just because the GPU isn't amazing, or even more computationally challenging problems I'm able to train on using Google Colab's CPU or GPU. But if you want, Databricks also supports using AWS. So if you have any AWS, like I think their tokens, you're able to leverage their online computing resources. So that is an option as well. But yeah, so another benefit of notebooks is that you're able to include Markdown, so it allows for really clear understanding of the code, and it helps support your code to better understand it. So let's start talking about how exactly to use a notebook and some of the features that it offers. So notebooks are comprised of text and cells. So this first cell where I have my cursor, I'm just printing welcome to the Dataverse, and it runs like a Python shell, which is one of the super useful parts about notebooks, is that you can run snippets of them. You don't have to run entire like Python files, for example, which means that you're able to really quickly edit and re-execute snippets of code, which is super important. So how you run snippets or cells is by clicking the play icon. That's one way. You can do Shift Enter, or you can go to the Runtime tab and run Selection. Those are three different ways of running a cell. Oh, sorry, I'm skipping one other section I wanted to mention is that notebooks or Google Colab notebooks have RAM and disk size limitations. So if you look to the top right, you'll see that I have about 13 gigabytes of RAM and 78 gigabytes of disk storage, which I think is actually less than normal. I'm not sure why that is. Normally it's like around 100. But one thing to note is that if you're going to be using a Google Colab notebook for your project, if you're using a very large data set, you won't be able to load it directly into your notebook. So what you can do is instead you can use pipelining. And we actually happen to have a workshop that goes into depth about how you can do that. That was done over this past summer. So again, if you're looking to use a very large data set, then you might want to check out that workshop here. As I said before, Google Colab has a hardware accelerator. So how you leverage that is you go to Runtime, you go to change, what was it again? Sorry, you go to change runtime type, and then you can specify your hardware accelerator. If you haven't done it, then it will be preset on none. I've already set it to GPU. Because once you save, you'll have to restart your notebook session, meaning you lose like all your variables that have been stored in the notebook. I recommend that you guys use GPU because a lot of Python frameworks support GPU, so they automatically detect that you're using a hardware accelerator, as opposed to TPU, which stands for tensor processing unit, which is a newer type of hardware that isn't as commonly supported. So I'd recommend that you guys use the GPU. Okay, yeah, so as I said before, how you run a single cell, there's 3 different ways. You can also run all the cells, but in the same tab by going to runtime, run all. You can run all the cells before, all the cells after. Yeah. So what I wanted to do here is I wanted to show some of the features on this left-hand side of the notebook. So as you can see, we have a table of contents. So you can quickly, with the markdown, I can quickly jump between different sections of the notebook. So I'll just go back to the Google Colab features section. So that's one really nice feature. Another feature is that you can find and replace all by going to this like magnifying glass. And so if I wanted to test replace with there, I can replace or replace all, and you see that it replaces. So if I run this and I look to our variables, this is our variables tab. You'll see that I have this var as well as, oh, I didn't actually, oh, I do, sorry, yeah. Before it was test replace. So even though I've now changed the name of this variable, it still exists in the notebook, meaning that if I were to create a new code cell, oh, speaking of which, sorry, primary function of the notebook is you can create new cells by clicking this plus code button, and you can create like markdown sections by adding this text section, and you can delete them using the trash bin over here. Anyways, what I wanted to show was that even though I've now replaced this variable with a new name var, if I put test replace and I run the cell, it should still print out 10, which is something that a nice piece of function, nice piece of information that you might want to know. If you ever want to delete all of your variables, you can use this function or this command right here, reset. I won't be resetting it just because I've preloaded a lot of this data, this notebook already, just because I wanted to save time. So I'm just gonna say no. But if you did want to, you just type Y, and that would refresh all your variables. You might want to do that if like your variable naming becomes confusing, or you might just want to reset your session for some reason. So yeah. And then the last feature I'm going to talk about for Google Colab is the mounting feature that I was talking about before. So there's 2 ways you can do that. You can include this exact cell, and you can find this easily online by just searching like mount Google Drive in Notebook. So you can do that quite easily. But you can also go to this tab right here, and my notebook is already mounted, but if you click on this button, I'll be revoking access and assign. I don't want to do that because I've already, as I said, preloaded a lot of stuff. But that's one alternative way. As opposed to just running this, you can click on this button right here. And what that gives me is access to my files. So as I said before, I can access my files here, and I can like look around. So I have this UW folder, this UW Data Science Club folder, this workshop. This is actually where this notebook exists in my directory. So yeah, those are the, if you want to learn more, a more thorough, there's some more tools that you can use. Oh, I'll quickly say some other stuff about like individual cells. You can move them using these arrows up and down. You can link particular cells with this linking button. So if you want to share it to a friend, you can do that easily. That's another great part about Google Colab, is that it's easily shareable. So you can share notebooks with others. That's how you're all able to see it right now. This is like the settings button. So this is for changing some visual elements of the notebook in terms of like size and spacing and such. Miscellaneous, this was like an April Fool's thing that Google did, which is kind of funny. You can connect your GitHub account. This is the pro version, and this is the theme. Yeah, and then you can delete cells, as I said before. This is to get like a pop-out window so you can run a cell in isolation and create what's called a scratch cell. So this is separate from the rest of the notebook. Yeah, so that's pretty much like all the main features of a Google Colab notebook. I've just run through them super quickly. And if you want like a more thorough explanation, I've provided a link here that does a really great job of explaining even like more specific features that Google Colab notebooks provide. Okay, so let's move on to data sets, or namely dataset websites. So if this is your first data science project, you might be hesitant. You might not know where to start, and that can be intimidating, but I'm here to like give you some tips, and particularly in terms of like coming up with a topic, because something that you'll often find is that a bottleneck in terms of data science projects is often data. So sometimes you'll have this really great idea, and you want to investigate some particular thing, but when you go to look online for data, it doesn't exist, and that's always really frustrating. So oftentimes people will brainstorm ideas while also looking at data, and that can sometimes like inspire their ideas. So I've just opened up a bunch of the dataset websites that we provided. So this is Kegel in the datasets tab. Kegel is a great data science website. It hosts a bunch of data science competitions, and they're hosted regularly on a huge range of topics. So I'd highly recommend making an account and like checking it out. And you can learn a lot. There's discussion forums. There's available notebooks for competitions and for data sets. So it's a great website to familiarize yourself with. So what I'm going to do is I'm just going to look around a bit. You can see the popular data sets, trending data sets. You can even filter, and they've given some like keywords. So what I'm going to do is I'm going to look for like a classification data set, and I see that there's a bunch of classification data sets here. And I'm actually going to filter by the most votes. This is the data set that I'm using for this particular workshop. I recommend you don't pick like one of the most common data sets, just because it's harder to come up with like very super original applications. But if you're really convinced that there's some like you're looking at some really different insight about some data set, then I don't want to like tell people not to do that. So yeah. So I just click on this data set, and this is like the standard page that will come up. You'll tend to see some files here that are within the data set. For this particular one, we just have one CSV file, and they've provided some description about the contents of it. So it's a heart disease data set, and they provided a whole bunch of attributes. So age, sex, chest pain type, resting blood pressure, cholesterol, and several more. And they have some goal field, which they actually refer to as, well, they call it the target field actually, but here's just like, they provide some of the first several entries of this data set. The scrolling around, we can see they provide like a description of what each column refers to. And sometimes in Kegel, they won't show all the columns. Like as we can see here, it says 10 of 14 columns shown. So if we just scroll down, we'll see that the target column isn't shown. So if we just click apply, it will come up. And if we scroll all the way to the right, that's great. We can see now the targets for these entries, where 0 refers to that individual not having heart disease, and 1 referring to them having heart disease. And so if you were to come across this data set, for example, you might want to work on a classification problem. So using these features provided, can we determine whether an individual has heart disease? And so yeah, so this is just like an example of what a typical data science in Kegel looks like. You can downloading it just like using that download button. So I've just put it directly into my folder. yeah, so I've just put it directly into this folder. But if you're working like locally, you can, yeah, same thing. You can put it into your folder. I'm going to touch back quickly because it just reminded me of something. If you're working locally, you might potentially want to use a Jupyter notebook. Jupyter notebook requires that you have Anaconda though, so Jupyter explains that installation process. But yeah, if you're like collaborating with people though, Google Colab is super easy, as I said before. So that's why another reason why we recommend using it, as opposed to some like local version. So yeah, that's like Kegel. This is the Google dataset search. I'm going to go quickly because I want to talk about some of these libraries as well. So I'm just going to go quickly like look through one dataset for each of these. So yeah, Google dataset search isn't as great in like coming up with topics, I guess, because they don't like have as many filters and so on. But if you already know what you want to like work on, then it's a great resource to have. So like they provide this example, so COVID. So if we check this out, we can see a bunch of COVID data sets. And so like this one, COVID data in the US. So they tell us the available download formats. And to get it, we can go to their GitHub repo, just clicking on that. And we get information about this data set and a really detailed, a really detailed README. So that's always great. And if you're not familiar with GitHub, you can like you can clone repositories. So you can do that using Git. You can do git clone and then this HTTPS URL in the terminal. And you can also directly like download folders as well if you just, or not folders, I guess, files, individual files, I believe. Can't remember if you can do folders. I assume you can, but your best bet is just to like clone the entire repo and work with it that way. So yeah, that's an example of a data set from Google dataset search. So here's data.gov. This is a great resource for like that data.gov data sets will be very well described, and they have a bunch of categories. And so yeah, I won't spend too much time on that, but but you can see that they have like some good filters on the left-hand side for finding data sets. So you're welcome to use this resource. Papers with Code is a great resource as well. So what I really like about them is that they filter by the type of data. They do a great job of filtering that, as well as the task, which is awesome. So if you're set on wanting to work on like some pose estimation problem, they have a filter for that, which is great. So I recommend checking out Papers with Code. As well, another feature of them is that they like provide a bunch of papers. So maybe you want to check out some papers and some of the methods that people use for particular data sets, and that can maybe give you inspiration for changing it in some way and applying it to a different data set. And then the last data set website I'm going to look at is Hugging Face. So Hugging Face is a great resource for language models. So if you want to work on like a natural language processing project, this is a great place to check out. So here we have this Rotten Tomatoes data set. So so this is what it looks like. It has a bunch of information about it. And yeah, so if you want to like work with transformers, which is like a commonly used way of transformers and natural language processing goes hand in hand, and that also is a reading group topic. So if that this is an area that interests you, I'd highly recommend checking out some of the natural language processing materials that the Waterloo Data Science Club offers, but also check out Hugging Face data sets. So yeah, let's move on to pandas. So If you've never used Pandas before, here's just a quick summary of what it does. It's a data manipulation and analysis library, and it's commonly used for handling and examining data sets. The two main data structures that Pandas has are series and data frames, and just a quick definition of both. A series is an array that can hold integers, strings, floats, Python objects, and more. You can kind of think of it as like a column, an individual column of a table. And a data frame is a two-dimensional labeled structure that contains columns. And like series, these columns can have different types. And so, yeah, you can think of data frames as spreadsheets or tables. And I provided a tutorial which has like a more thorough documentation. But below here, I'm just going to go back to the table of contents on the left to see where we're at. I've provided some example implementations of some of the two main structures. So here's how you create a series. Or first, I'm just importing the Pandas library, and I'm giving it the alias PD. So this is like you'll very commonly see this alias used with Pandas. So if you ever see PD, just think data set or handling data sets. So right here, I'm just creating a simple series object, and I'm printing it. So has 4 integers. Yeah, so dtype int 64. Right here, I am creating a data frame, and it has 4 columns, A, B, C, D. And as you can see, it has different types. So it has like an integer, it has like a timestamp data, it has categorical. So it's like different, categorical meaning like different classes basically. And then it has just a string. Moving on to some essential functions of Pandas. So this cell right here is like super important. One of the great features of Pandas is that it has great I/O in terms of like whatever format your data set is in, you'll likely be able to find a function in which you can read it in to your notebook. So for example, right here, I'm using read underscore CSV, but there's like read Excel, there's read XML, there's read JSON, there's a whole bunch of other read functions for whatever your data set format is. And you can find them all at this link right here. And how you reference, so if you're in a Google Colab notebook, you're going to want to include the pathway to your file. So so if I go down here, as I showed before, so this is my Google Drive. So go G Drive. So actually, sorry, you start off with content and then G Drive. So that's what you've like mounted it to. If I go back up, you always start off with that in your pathway. And then I go into my drive, UW Data Science Club, Toolkit Workshop, and then this is the actual CSV file. And what you can do is if you click on these 3 dots, you can copy the path and then copy it in like that. So that's just another way of making sure you don't have errors. I know I've in the past have like been stuck in a notebook for a long time and then realized that like my pathway was wrong and that was like what was causing it. So so yeah, just a cool tip that's so nice to know. So yeah, here I'm using integer-based indexing. So basically, I've read in my data set, the heart disease data set, into a variable called df. It's a data frame, so it's one of these 2 structures I talked about before. And I'm using integer-based indexing. So right here, I'm looking at the first 3 entries of this data set. So if you guys remember, you can see that there's the age, the sex, the cholesterol, I think this is resting heartbeat column, and the target column on the right. And so you can reference reference entire entries, or you can even reference like individual values. So right here, I'm referencing the second or the third entry of the 0th column where it's indexed from 0. If you're familiar with other like programming languages, in general, like a lot of arrays are indexed from 0, so this is the same. Here I'm using named-based indexing, so just wanted you guys to be aware that you're able to do that. And you can also, I should be able to, just for demonstration purposes, if I do a double brackets around it. I can reference like more than one at a time. So if I do like sex, it shows both these two columns together. Another nice to know feature. And then this last one is also super important. It's converting your data frame to NumPy. So oftentimes you won't necessarily convert your entire data frame to NumPy, but you might like convert several entries at a time. So you can like reference, or you can reference like an individual column and convert it to NumPy. And why we do this is because, as I'll explain in the next topic, which is NumPy. NumPy is like a super powerful library that's used throughout data science, and being able to convert between the structures needed is important. So this function is super critical. So just nice to be aware of. Here are some visualization tools. So for looking at your data set, so df.columns, this shows the columns of your data set. The head function shows you the first 5 entries of your data set by default, but you can specify how many entries you want to look at. The tail function looks at the last 5 entries. The describe function generates some statistics for your data set. So we can see that there are 303 entries in our data set. The mean age is 54.36 years. Standard deviation is 9. The youngest person in this data set is 29 years old, and the oldest is 77, as well as we can see quartiles. And yeah, so that's a useful function to help you understand your data set better. Similarly, this is a function that creates a correlation matrix. So you can see if you're familiar with statistics, this is like being able to understand the relation between two different attributes. So as you can see on the left, we have all the different columns. And on the top, we also have the columns, which means that across the diagonal, we see that there's the correlation between the two variables are 1, meaning that they're directly correlated. So, which makes sense because we're comparing the same column to itself, which makes sense. And then finally, here's the function hist. So it's just an easy way of creating a histogram for a given column. So right here, I'm creating a histogram for cholesterol, just a nice, easy tool for visualizing some particular values in your data set. So yeah, again, so that's all I'm going to talk about Pandas. It's pretty like surface level. It's fairly surface level. I'm just showing like some really critical, often used functions. But if you want like a more thorough explanation, you can go to their documentation, and I provided a link that has like a great tutorial on some more operations that you can do. So yeah, now we're on to Numpy. So Numpy is a Python library that is highly optimized. And so if you guys attended the keynote, you'll know that one of the topics talked about was computationally taxing operations. And even 15 years ago, or 15 years ago, 10 years ago, even since then, we've made like huge gains in terms of like optimizing operations, and that's in large part to NumPy. And the core object in NumPy is this thing called the ND array, which basically is it interprets everything as it allows variables to be up to any number of dimensions, which is super powerful. And many of the operations that I'll be talking about in a few seconds are optimized, or like highly optimized by super knowledgeable mathematicians and computer scientists. So it's great that they've provided this implementation free of charge. And so how you use it is you first have to import it, and you give it this alias, or you don't have to give it this alias. Again, this is like similar to Pandas and PD. It's just like a very common alias that's used. So if you see NP, just think NumPy. So here's a function zeros, which just creates an array of zeros. Similarly, here's a function called ones, which creates an array of ones. And you might be thinking like, oh, why this seems like not very helpful or unnecessary. When in reality, there are some particular machine learning techniques such as like regression analysis, where you need to create an array of ones and concatenate that to your data set in order to properly train your model. And so just being aware of these is oftentimes quite useful. And so, yeah, I wanted to include that. Here's this function linspace, which makes an evenly spaced array where the first number is the starting point, the second input is the endpoint, and the third number is the number of samples. So as you can see, I'm just creating an array from 0 to 1 with 5 samples. This next function, arrange, is similar, except that you make an evenly spaced array with a start and end input, but then we have the step size. So you can see that we're going from 3 to 12 with a step size of 2. The next function is creating an identity matrix, and you can use that with the I function. It's like a what's the term for that? I'm forgetting the homophone, like I versus I, same sound. And that's like standard across MATLAB as well and some other programming languages, just for reference. Yeah, so here's how you make a NumPy array. So you do np.array, and you can input like an array. You can also input like entire data. You can input like much larger arrays as well. And right here, I'm just printing what it looks like as well as the shape. And so that's a super useful function. As well, reshape. This is like a super important one because oftentimes you'll have to reshape your data numerous times to fit with whatever your model limitations are. And so just being aware of this function is super important. Concatenate, as I said before, is useful. In that example I referenced about concatenating an array of ones to my data set. You can transpose arrays easily. I also wanted to make a note that that NumPy supports NaN, which stands for not a number. And it basically means that the value is undefined, so it hasn't been specified yet. And so, yeah, that's basically the main functions of NumPy that I wanted to show. There's many, many more. And so if you find that, if you think that there is some operation that you want to do on a matrix or array, and you're having to like use some loop or something like that, chances are that there exists some implementation already in NumPy. So I'd recommend you can check out this really comprehensive yet concise resource, as well as like the documentation for NumPy directly. This is like a separate, I think it's like a textbook, but I thought it was really well done, so I referenced that as well. Okay, so now we're on to Matplotlib and Seaborn. So these are two plotting libraries. Matplotlib is as I said, a plotting library and extends NumPy, and it provides a super comprehensive API for both static and animated visualizations, and it can create a whole range of plots, including scatter plots, box plots, line graphs, pie graphs, and more. And Seaborn is also, it's a more statistical graphing library, so but it's built upon Matplotlib, and it can aid your exploration and understanding of the data. And you can learn more about both of them at the links I've provided here. So right here, I'm just importing both libraries, and I'm giving them the alias PLT and SNS. Again, this two standard aliases that are used, so I just wanted you all to be aware of them. So right here, I'm using Matplotlib to plot some of the data from our data set that we had before, the heart disease one. So I'm going to be plotting the age versus cholesterol with a scatter plot. So I do that just by first creating a figure, and then I use the scatter function. I use the grid to provide the grid line. So yeah, the grid lines in our figure, as well as an X and Y label to label our figure and a title. And this is what we get below. So this is like a quick way of coming up with a graph for two variables. And there's a whole bunch of other different plotting functions as well. As I said before, there's like a box plot function, there's a line graph function, there's a pie graph function. So you can check all those out at the Matplotlib library documentation I provided above. But here's a really cool tool that Seaborn offers. It's called pairplot, and what it does is it very concisely compares two variables against each other for like a bunch of different variables. So what I'm providing here is the data frame that we're working with, as well as the X variables and the Y variables that I want to be compared. And what I get is below. And this is like a really awesome visualization comparing variables against each other. And this can be super useful when you find a data set and you're not exactly sure what variables or what attributes are important, and even like what techniques you might want to use. I'd highly recommend visualizing your data set, that being like one of your first steps in order to like better understand your data. So using a pair plot can oftentimes be really helpful in helping you understand like visually the correlation between two attributes. So this is a great function I recommend you guys checking out and trying for yourself. Okay, cool. So now we're on to Scikit-Learn. So Scikit-Learn is an open source machine learning library, and it has 6 main features, which I've listed. So they're classification, regression, clustering, dimensionality reduction, model selection, and pre-processing. I don't have time to really talk about all of these in depth in terms of the implementation details, but I've tried to provide as much like markdown information as well as some cells about the important modules that you might want to further look into. As well, I talk a bit about 3 of these applications, the first 3, classification, regression, and clustering, just because those are the most relevant. Those are the most directly relevant to working on tasks. So I'll give a quick rundown of dimensionality reduction though. Dimensionality reduction can accompany your project by, as the name implies, reducing the dimension of your data, and that oftentimes can improve your model performance when you find that there are too many attributes and that many of them have no correlation to what you're trying to classify or predict on. And so you can use dimensionality reduction techniques if you find later on in your project, maybe on Saturday night or Sunday morning, that you want to improve your model. This might be something that you want to look into more. And Scikit-Learn provides a bunch of useful workshops and tutorials that talk about that. And so as well, in addition to these 6 applications, though, there are a bunch of related packages. So that interoperate with Scikit-Learn, and some examples of that include the surprise package, which is really useful for recommender systems, as well as the natural language toolkit, commonly abbreviated to NLTK, which works with natural language processing. So both of them both of those 2 packages are really awesome, and they work well with they work well with Scikit-Learn in terms of like data preparation and whatnot. And so you can learn more about those 2 packages and others. There's a ton of other projects that are related to Scikit-Learn just because of how big and important of a library this is. So you can check out some of those other packages and projects at this link provided. As well, the Data Science Club has a previous workshop entirely dedicated to this one library. So I think it's like an hour and a half. You don't have to watch the entire thing, but that just goes to show like how important of a library this is. And honestly, I think all of these libraries that I've talked about, like Pandas, Numpy, Matplotlib, Scikit-Learn, TensorFlow, honestly, all of these libraries in of themselves could have their own workshop for an hour and a half. So that's kind of why I'm just trying to convey like the basic functionality of each. But I highly recommend that you use this workshop as a way of like of basically knowing where to look into further, and potentially drawing inspiration on like what you want your project to be. Okay, so let's look into the first application, classification. So classification refers to a type of task which requires machine learning algorithms to assign labels to data, labels just being like outputs and the classes of that data. So some applications of classification include span detection, fraud detection, handwritten digit classification, and more. And I've provided like a photo of some handwritten digits and their associated labels. And some classification algorithms that Scikit-Learn supports are support vector machines, decision trees, random forest classifiers, and more. And so I'd recommend if you want to work on a classification problem, you might want to check out some of these algorithms that I've mentioned, as well as the implementations. I wanted to note that SVMs are one of the workshops that we did this term. So if you do use an SVM, you'll actually be eligible for the workshop prize. So maybe that's more incentive to check it out. And you get these, and so the modules that specifically to refer to each of these algorithms that I mentioned, I've put in the cell. And so I recommend that you guys check out the documentation on Scikit-Learn's website to further understand how to use them. They have some great tutorials that are really transferable to whatever your data set is. Okay, the next application is regression. So a quick definition of like what regression is in case you didn't know. Regression analysis refers to a set of statistical methods used for estimating the relationship between a dependent variable and independent variables, usually many independent variables. I provided a picture here, which kind of shows an example of this. So this picture is showing square feet versus house price, and we're wanting to know if there's some relationship between the two. And so you might use different regression methods such as linear regression or polynomial regression to model this data and then make predictions based on this model data. As well, logistic regression is a classification algorithm, and it is an alternative to some of the classification algorithms I mentioned up here, like SVMs, decision trees, random forest. So again, if you're working on a classification problem, you might want to check out logistic regression as well. Similarly, I actually did a workshop on this at the beginning of the term. So again, I spent like an hour on this topic alone. So I'm really trying to like condense a lot of like the vital information, giving like a brief explanation of what regression is, as well as the associated modules that I used. So yeah, these are the associated modules I used. So I recommend checking out some tutorials on that on the Scikit-Learn website. And so yeah, the last application I'm going to look at is clustering. So clustering refers to the task of grouping data in such a way that objects in the same group are more similar to each other than those in other groups. So what that means is that you can use clustering as a way of finding the underlying structure in data. And that's a really big advantage because oftentimes it's much more difficult to get labeled data versus unlabeled data. Now, if you're getting data sets from many of these websites that we provided, it's very likely those data sets are labeled just because a lot of they're well curated, and but if you're trying to make your own, then that might be quite difficult because the labeling process in of itself is quite time consuming. And again, if you were at the keynote, that was one of the things that was mentioned, that unlabeled data is much easier to come by. Like you can download zillions of images, but it's much harder to label that many images. So using clustering is often a great technique when you don't know the labels. But even if you do know the labels, it can be interesting to use clustering because maybe the labels, there's some other pattern that exists in your data set that your labels don't actually pick up on. So again, we had a workshop on this, an entire workshop on this topic. So if this technique interests you, I'd highly recommend checking it out. It talks about like the theory behind clustering as well as more implementation details on how to use it. But if you're in a rush, then you can check out some of these modules that I provided on the cluster, or some of these functions that I provided in the cluster module on the Scikit-Learn website. And yeah, these are three: k-means clustering, mean shift clustering, and db-scan clustering. There are three different clustering algorithms for three kind of different situations depending on the type of data that you have. So yeah, if this interests you, I highly recommend checking out that workshop. Okay, so the last library that I'm going to talk about is TensorFlow and Keras. So they tend to go hand in hand. Keras is like an interface for TensorFlow. But first to explain what TensorFlow is. So TensorFlow is an open source machine learning library that is used for creating artificial neural networks. If you've never heard of an artificial neural network, they're commonly called neural networks, but I just wanted to be more technically precise. Also because I wanted to say that it's a technique that's inspired by biological neural networks. So I wanted to distinguish between the two. And basically, it's a machine learning technique that attempts to mimic the process of how animals learn. And it's a really cool technique that's commonly used for, again, classification tasks, as well as sequence recognition. And you can learn more about TensorFlow at the link I provided. This image is just a super basic neural network where we have a 2-neuron input layer, a 2-neuron hidden layer, and then a single neuron output layer. I won't get into too much detail about like the math or that's going on there, but if that does interest you, we have multiple workshops on this topic. As well, we have a workshop entirely dedicated to neural networks in TensorFlow. So if this is a technique that interests you, that you want to work on a project, spend the weekend learning about, I'd recommend you checking out that workshop. So yeah, as I said, Keras is an interface for TensorFlow, and it contains many of the building blocks of a neural network. So as I said, when I was describing this image, each of these circles are what are called neurons, and we separate our neural network into layers. And so Keras has implementations of these common building blocks, such as layers, activation functions, optimizers. These are some terms I won't get into specifically because they're kind of beyond the scope of this workshop, but they're essential to how neural networks actually learn. So you're welcome to search up activation functions and optimizers on YouTube or on Google, or just watch one of our workshops. And so yeah, if this interests you. I wanted to note that PyTorch is another alternative that does very similar things to TensorFlow. It's more object-oriented, so if that appeals to you, you might want to check out PyTorch. They have great documentation as well, so that's another option. The reason I slightly prefer TensorFlow and Keras is just because I find the API is a bit more. It does a bit more, to be honest. So you can create neural networks like more concisely, which is nice. And also, I really like Keras. Keras is like great for data augmentation and pre-processing. So if you're working on some image classification project, I recommend using TensorFlow and Keras, because Keras is great for like creating more images, and it's great for actually loading your images into your model, which I'm going to talk a bit about in a second. So here are some really basic TensorFlow cells. So right here, I'm just importing TensorFlow as TF, and then I'm also importing Keras. In the second cell, I am importing the sequential function as well as the sequential object, as well as the layers module. And in this cell 43, I am creating a simple sequential model where I'm creating a sequential object, and then I'm adding layers to it. Basically, the sequential object is just used to create a linear stack of layers, as opposed to other different neural network architectures. There are tons of different neural network architectures, and many of them have particular applications. So this is just one type of architecture where we have them flowing all in the same direction. So what I'm doing is I'm just adding what's called a dense layer, as well as I'm specifying the activation for that layer. And these numbers, refer to the number of neurons in that layer. So first, I'm specifying the input shape. So I want a 3x1 input into our model, and then our first layer actually has 3 neurons for each of those inputs. Our hidden layer has 4 neurons, and our output layer has 2 neurons, and I've specified the activation function to be softmax. That's like typical for classification problems. The softmax activation function is basically, it was created for that purpose. Again, I don't want to, it has to do with like probabilities, and basically depending on the output of a neuron in the output layer, that's what determines what your model is essentially predicting. So yeah, and I haven't provided the entire implementation just because, again, that goes like kind of beyond the scope of this workshop. But if you want to use a neural network for a project, what you'll have to do after creating your model is you'll want to compile it, and you'll need to specify the optimizer and loss functions. And you can learn more about what those terms are on the TensorFlow website, as well as other resources. And to train the model, you'll need to use the fit function and specify 4 things: the training data, the labels, the batch size, and the number of epochs. And to make predictions with your model, you'll just use the predict function and specify the testing samples. And that's really important because specifically the testing samples part, I think I forgot to I'll circle around actually about that at the end. So yeah, this is the last slide, the last cell though. So Keras preprocessing, as I said, super useful, and one of the reasons I love using TensorFlow in particular. So it's a super comprehensive API. It has a super comprehensive API for data augmentation, and this module in particular, image dataset from directory, is really awesome. So you can basically have a folder in your project that has training images. Then you can have another folder that has testing images, and so what you can do is, by using this module, it has built-in data augmentation. So you can learn more about that implementation right here. I'll actually quickly go to it and just show you guys what I'm referring to. Basically, this little code snippet here does exactly what I was referring to. In that right here is where this is the function which you have options to do some data augmentation. In this example, they're not actually, or at least I don't see that they are, but you can look more closely at this particular function and you'll see that it has options. It has other options as well. And in terms of like shuffling and stuff as well, I believe you can do crop. Yeah, you can do cropped aspect ratios as well. So yeah, I just wanted to show that function quickly. Just before we wrap up, I wanted to circle back to one cell in particular, because I think I glossed over it. Yeah, it was these 2 cells. These 2 cells are actually, yeah, these 2 cells are really important, and I'm glad I remembered and didn't forget to talk about them. So yeah, jumping back to the Scikit-Learn library, what I'm doing here is I'm just importing the Scikit-Learn library, and in particular, this function, this train test split function, is super awesome. And basically what it does is it splits your data into a training set and a testing set for you, and it does it with this function. And so what I'm doing is I'm specifying 2 attributes in our data set: the age and the cholesterol attributes. As well, I'm specifying the labels, which is the target attribute, and I'm specifying our testing set size as 0.2, as well as the random state. That's for reproducibility purposes. And basically, I give it 4 variables, and in this exact order, you go your training data, your testing data, your training labels, your testing labels, and it automatically splits your data set into the appropriate sizes. So like 0.8% of your entire data set is going to be training, and 0.2 it's going to be testing. And that's important because of the concept of overfitting and underfitting. So you want to train your models on enough data so that it can learn about some pattern that exists, but you don't want to train on the entirety of your data set because it can do what's called overfitting, which is when your model is unable to generalize to unseen data. So you always want to split your data set into training and testing. And it's also critical for actually assessing your model. You can't assess your model on training data because your model's already seen that before. Oh, well, it's good. I'm pretty much finished, so I don't think this is an issue. But yeah, so this function is super important. That Scikit-Learn provides as well. This metrics module is super awesome, and you can learn more about that at this link. Yeah, that takes a while to explain. So I think that's pretty much the end of this workshop. I've provided some more resources at the bottom, and yeah, I'm happy to take any questions from anyone. So yeah. I see some of the execs have been answering questions in the chat, which is awesome. What would be like a limit for dataset size to use in notebooks without pipeline? Good question, Sunil. So yeah, I don't actually know, like I can't tell you like a definitive size, but I can give you some maybe. So well, the first thing to note is that you can try it, and if you notice that, I'm just going to reconnect to the notebook. You can try it, and then if you notice your disk is out of space, like it's your notebook stops working, that's an indicator. But like generally that happens in industry when you're working with like ginormous data sets, which do exist on these websites. But yeah, that's one way to know if you should be using pipelining or not, if your notebook isn't working. And in which case, if you are using a really big data set, as I said before, yeah, you can use pipelining, and that involves many of the libraries I've already talked about. There are more specific functions, but yeah, like Pandas and Numpy are part of the pipelining process. As well, if you guys have, while I know I gave like a kind of a surface level explanation about these libraries, I just wanted to show you like the most essential functions of each of them. And so during this weekend, if you guys read more documentation or have questions about particular libraries, you're more than welcome to ask me them. I'll be happy to spend some time trying to answer your questions. And yeah. So I'm just going to go back to the top. Or actually, I'm going to go to the resources in case anyone wants to write them down. By this point, if anyone came in late, I'll actually go back to the top. I'm going to send the notebook